Next, let me share 3 case studies from the work we do that elaborates what we mean by digitalization made real. How we manage to operate in both worlds at the same time and provide meaningful contributions to the world and profitable solutions to our customers. A few observations. I'm sure you saw them too. Digital controls offer faster loop times and iterations than mechanical feedback via springs or hydraulics. Reducing pollution is a cool way to apply the intrinsic strength of this technology. But as we appreciate from the dirt and grime of the engineers in the engine room, the retrofit of the digital control require a lot of greased elbows and head bumps. You may not have the experience of working in a small engine room, but you will have dealt with wires of your computer or your TV system when you first set them up. You would have had to crawl behind the cabinets to affix a jungle of wires. After that, you can relax in the couch with the remote control. Real-world attitude. We didn't wait for an AutoCAD model of the engine and another of the vessel. Neither of them exist. We found a place to bolt on the control box and figured out the wiring path. Digitalization benefit achieved. Next case study. This is based on the same concept of using digital technology to more accurately control an engine. But with the confidence from retrofitting the ship's engine, we took it to a larger scale. This time, we managed to digitally enhance the steam turbine generator in a sugar plant. Steam is needed in a sugar plant to extract sugar from sugar cane. Essentially, we are cooking the sugar out of the cane with steam. Steam is generated from large boilers. Some of it feeds into the sugar extraction process, but the rest is fed into a steam turbine to generate electricity. Electricity, in turn, is used to power machines such as the escalator conveyor in the picture, which carries the sugarcane to the top of the crushing towers. In most plants, the steam turbine generates more electricity than is consumed by the plant, for a variety of reasons. Processes are not always continuous and depend on the volume of cane harvested and fed into the plant. With digital controls, it is possible to finely regulate the quality of the electricity produced by the steam turbine. Producing better quality electricity qualifies the plant to supply excess power to the public grid. Previously, when there was no digital controls, the electricity fluctuates anywhere from 10% and upwards. After the project, we managed to get the quality to ±2% or less. And with further automation, the plant could precisely determine its factory loads and maximize the sale of excess electrical power to the grid. It also meant that any savings in the electricity or energy efficiencies in the plant turns almost immediately to cash. Now, let's look at the third and final case study. The client is a chemical plant. It is not unlike the one in the picture you see at the bottom of this slide. A multi-million-dollar complex of pipes, reactors, chimneys, representative of the multiple stages of chemical production. Frankly, we come across pictures like this more and more often, and they provide beautiful backdrops in our exhibition booths. Question is, how do you get from the bottom picture to the picture on the top left corner with data streaming out of every pipe and pump to the image in the top right corner where we get to the realm of artificial intelligence and machine learning? The exhibitors and thought leaders here will agree and advise you that digitalization is a journey, and we all want you eagerly to take the first step. But where we differ is our different advice on what this first step should be. Some will advocate to start with augmented reality. Some will say, automate part of your production line with robots. Some will aim straight at top management. Mr. CEO, don't you wish you have a dashboard to check on everything from operations to profits? And here's our cloud-based do-everything solution. And here's our virtual command center. And here's our team of experts and digital scientists. All of this is super exciting. What is the first step that our customer took? This question gives me the opportunity to take you to my exhibition booth. If you have not come across it, please feel free to drop by after this mini conference. In the case of our customer, digitalization starts with a switchgear. That's the first step they took. And reflecting on our work with them, we thought their example can benefit many more customers like you. At the SWTS exhibition booth, we are displaying a medium voltage switchgear. It is the NX Plus series from Siemens. A switchgear is basically a protection device, like the circuit breakers at home. Home breakers trip if your toaster short circuits, isolating it so that your TV or aircon keeps running safely. Same principle, just much bigger. The reason industrial switchgears are so large is because they deal with very high voltages and large currents. They have to be constructed of rigid materials to withstand large forces when the current breaks off, and insulated with gas so that arcing is prevented and or quenched within microseconds. It's a pity that most people will never see the quality engineering within a switchgear because the components inside are double-walled and sealed with gas. The display unit in our booth has a window and is nicely lighted, so do come and take a look. Switchgears sit at the heart of the plant's energy distribution system. Marked in red outline here, the MV switchgears in the plant's substation take in power from the utility, marked in the orange, and spreads it across to smaller groups of equipment. In many cases, there are low voltage switchgears that provide a third layer of distribution, marked in green. After that, we get down to the individual motors, marked in the blue. The illustration on the right shows the concept in 3D. You see the switchgears, motor controls and drives in one room with lines leading to a row of motors and so on. But the picture also shows clearly the potential for information and data flows along the same network. Starting your digital data collection at the MV switchgear level is a clever first step for two related reasons. The first reason has to do with choosing to collect energy consumption data. I will get to that later. The second reason is because it strikes a reasonable balance between too little and too much data. Above the MV line, the plant receives a single bill from the utility. You will then have the unenviable task to cross-check this lump sum bill with your plant's energy usage. At the MV line, you now get energy data divided into 10 or more segments. Even for mathematically challenged decision makers, there is no reason a set of data in 10 to 50 segments cannot be presented and understood. It will not be difficult to pick out high consumption in 1 to 2 segments and get those in charge to focus attention on them. At the LV line of switchboards, MCCs and drives, we get into thousands of sets of data. At the final line of individual motors, which essentially is what the Internet of Things is about, we are talking thousands if not tens of thousands of sets of data. So let me summarize and conclude. If you are wondering how to kickstart your digitization journey and are overwhelmed by the endless stream of choices and options, let SWTS help you with the simple step of starting with the energy data from your switchgear. The best engineering proposals are business plans, and plans with tangible savings get approved. Energy savings are tangible and clear-cut. I have come across engineering proposals that make use of other justifications. I will highlight 3 common ones and their difficulties. Obsolescence. Dear management, our equipment is old and spare parts may be hard or impossible to find. Dear management, new and more efficient machines exist. We must keep up or fall behind our competitors. To management, these are valid reasons but have to be weighed against other considerations. It is a question of degree. How much longer can we stretch the present operations? Which machine is more obsolete than the others? Condition monitoring or CM. The classic IoT condition monitoring argument promises prolonged machine life and no more unexpected failures. The trouble with this argument is not in its logic. It has perfect logic. The trouble is quantifying and achieving the savings, because you will find yourself waist deep in probabilities. How much longer will the machine probably last? What is the probability of an unexpected failure occurring at the time of highest production? Correlate this with the probabilities that what is produced will be sold at that instance at maximum profit. Condition monitoring is like swallowing vitamins. You know that they are good, you consume them, But you cannot swallow every single vitamin there is. And if vitamins double in price, I'm sure you'll stop and think twice. Labor saving. This is a serious subject that ultimately concerns not just your proposal, but the entire human race. Will robots replace us? If they do, is it good or bad? If it's good, good for whom? Take data collection. With the automation network that you build, data collection is instantaneous and automatic. No need for any worker to walk the path, read dials, and fill out logbooks. In your proposal, you quantify the savings in man-hours. In reality, can management post that worker to the data center and reassign him or her the job of data analytics instead? Practically, this seldom ends well. Labor savings is an obvious argument, but a painful pill for managers to swallow. Therefore, let me steer us back to energy management, and this includes carbon management, by the way. If you have not picked this up, it is the smartest move by far among all that's been discussed today. The trick is really to get going. The secret is that the energy data network that you build with management support will also double up as the network for future digitalization projects. Process automation, DCS, SCADA, MindSphere, AI, all that will be built up from the same data architecture. Thank you for listening. What I've just shared, I believe, is truly what Digitalization Made Real is all about. I wish you a successful and prosperous digitalization journey. I wish you a wonderful double adventure in the digital and the real world. I can be reached at mktg@swts.com for comments and inquiries. See you at the show and beyond. Thank you.